Hello everyone, welcome back. In this video today, we're going to talk about two different things. First, we're going to talk about solving radical equations, and then we are going to talk about average rate of change. So these are two slightly different topics, but because we covered them in the same class period, we are going to talk about them both in this same video. So here we have some example problems, but before we go ahead and start them, I want to remind us of the 4 steps to solving radical equations, because solving radical equations is a little different than solving some of the types of equations we've solved before. So I'm just going to go ahead and write a list of the steps. So the first step is going to be to isolate the radical. Right? In other words, isolate the part that is just the square root. Get everything else on the other side of the equation so that one side of the equation is just the stuff that is under the square root symbol. After we isolate the radical, we are going to undo the radical. In other words, we are either going to square the function or we are going to cube the function, right? Whichever is the opposite of what is in the given equation. So if we have an equation with a square root, we will square it. If we have an equation with a cubed root, we will cube it. And then once the radical is gone, we will finish solving. And that means we're going to keep working until we have our variable is equal to some number. Where we sort of stray from how other types of problems worked is that the 4th step is critical here, and that is that we check for extraneous solutions. So if you remember, an extraneous solution is a solution that you get from correctly solving, right? You follow all those steps, you do everything correctly, and you get this answer at the end. But when I plug it back into my original, it doesn't work out. The two sides of the equation are not equal to each other. Okay, and that is going to happen with radical functions when we have a square root. Not in every problem, but it will happen sometimes. And that comes from the fact that a negative number squared is a positive number, right? So that kind of messes with things sometimes. So we always have to check for extraneous solutions. Okay. Now that we've covered that, I'm going to take some example problems and go through those steps. So I'm going to actually start with number 3. I don't know why, it just looks like a nice problem to me. But I'm going to go ahead and try to solve that. So my first step is to isolate the radical. So I find my term with the radical is right here. It's just the square root of x, okay? So I want that by itself. And in order to get that by itself, I'm going to have to get rid of that plus 15 that's happening right after it. So I'm going to go ahead and subtract 15 from both sides. Oh, my pen is working absolutely horribly. Sorry about that. Okay, well, when I do that, I'm left with 7 is equal to the square root of x. Okay, step 1 is done. My radical has been isolated. So now I'm on to step 2. I have to undo this radical. And since this is a square root, to undo it, I'm going to square it. But what I do to one side, I have to do to the other. So I'm actually squaring both sides. And this leaves me with 49, right, from 7 squared, is equal to x. Okay, remember this right side is just left with x because that squared and square root, since they're opposites, they cancel each other out. So that stuff's all gone, and it just leaves us with what was under the square root symbol, under the radical to begin with, which was x. Okay. So I finished solving. That was step 3. Step 4 is check for extraneous solutions. So I'm going to go ahead and check my work. And what I mean by check my work is to write this original equation out again, exactly as is, except I'm going to take the value I got for x, and I'm going to substitute that instead of writing x. So, oh my goodness. This part of the screen, y'all. Really? Just got this nice new touchscreen computer, and it kind of annoys me because not the whole screen works, but I guess I'll get past it. Okay, anyways, so we have 22 on the left, and then on the right we have the square root of x. So this time I'm going to write square root of 49, and then plus 15. Now, to see if the two sides are equal, And this is really important. Some people are trying to like subtract terms from both sides here. They're trying to like do things that look more like solving an equation. Take a moment, take a breath, look at this right here. There is no variable here. So there is no reason for you to be moving certain terms from one side of the equal side to the other. What I want to do is just check that both sides of the equal sign are equal to each other. So I want to simplify each side on its own until each side is just a number. I already have that with the left side. So on the left side here, I have the number 22. So I'm just going to copy that down. On the right side, there is something to simplify. I have the square root of 49 plus 15. If I take the square root of 49, that gives me the number 7. And then I copy down the plus 15. Moving on once again, still simplifying that right side, when I add 7 and 15 together, I do in fact get 22. So, while it doesn't necessarily look like it because my screen is broken and the 22 on the left is super sloppy, both sides do indeed equal 22. So this question, the solution checks out. So it is not an extraneous solution, it is a real solution. So my solution is x is equal to 49. Okay. Now let's move on to another question. What's another one that I like? I'm gonna look at number 8. I might run out of space to finish this one right here, but we're gonna try to write small. Ooh, you know what I can do? I can make this bigger. Y'all are probably laughing at me because I'm like talking to myself, but really I'm talking to y'all because you're on the other side of the video, so. Oof, that's not what I meant to do. Okay. I don't know why it's freaking out. Okay, anyways, getting started, we are going to follow our same old steps. So, once again, the first step is to isolate the radical. So I want that square root symbol and everything under it by itself. In order to do that, I'm going to have to subtract 7 from both sides. Okay, when I do that, the 7's on the right, they cancel. I'm left with negative 8 is equal to the square root of 5x minus 1. Okay. My radical is now isolated. It is the only thing on the right side of this equation. Okay, so I can't do anything to the terms under the radical until I get rid of the radical. So I'm going to go ahead and do that. Again, I do that by squaring both sides, since squaring is the opposite of square root. Here is why I picked this example. If you were to write exactly as it says right now and type exactly like this into a calculator, this is not going to work out for you. When you are squaring both sides, remember you are squaring everything on each side. So on the right side, you are squaring that whole radical situation, and all that does is get rid of the radical symbol. On the left side, though, I have to square this number negative 8. And that is not the same as taking minus and then 8 squared. So what I have to do, and this is incredibly important, is I have to put that negative 8 in parentheses. I am squaring the number negative 8. I'm not doing negative and then 8 squared. Very different. Okay, and you will get a different answer. So if you're doing this math in your head, if you're putting it in a calculator, write those parentheses every time you have a negative number. Okay, then when I square negative 8, that's going to come to 64. Okay. And the right comes to 5x minus 1. Now I'm going to deal with this subtraction, so I'm going to add 1 to both sides. I'm left with 65 is equal to 5x. And then I'm going to divide both sides by 5. And when I do that, I end up with 13 is equal to x. So there's step 3. I finished solving. But before I say that this is for sure my solution, I have to do step 4. I have to check and see whether or not this is a real solution or an extraneous solution. Extraneous. I say that word 2 different ways. So if you want to say extraneous or extraneous, that's pretty much up to you. Okay. Anyways, moving on. Again, just a reminder that when we check, what we're doing is we're rewriting this original equation. It'd probably be easier if I erase that. Rewriting the original equation, but this time I'm plugging in the number 13 in place of x. So I have -1 is equal to the square root of 5 times 13 minus 1. Note that is all under the root symbol. Very, very important that we write this exactly. It's very easy to accidentally move something from under it to outside or move something from outside to under it. But be careful that exactly the same content is under the radical symbol. And anything that was outside of the radical symbol should still be outside the radical symbol. So yes, it does matter where the radical symbol ends. From here, once again, we're just simplifying. So I'm going to take all those numbers under the radical sign. I'm going to multiply. And if I take 5 times 13, I get 65. If I subtract 1, I get 64. So I'm just going to kind of do that all in one step here to save space. Okay. And again, I'm not doing anything with the left because that was already simplified. I'm just trying to simplify the right. The square root of 64 is 8. And 8 plus 7 gives me 15. So, what happened here? Well, those two numbers do not equal each other. So, what that tells me is that my solution that I got earlier is an extraneous solution. Okay? That is an extraneous solution. And what that means, how I would write this answer, and please ignore all of this in here right now. We're literally looking at the problem above that still. I'm just trying to find some space. What this tells me is that there are no real solutions. So what you should be writing on your page is that there are no real solutions. Okay? There is a solution, right? There is something that happens when I solve it, but it is not a real solution. It does not actually work when we plug it back in. So again, I shouldn't say no solutions. There is a solution, it's just extraneous. So it's no real solutions. Anyways, moving on. Now we're going to do one more problem, and I'm only doing one more because it is a cube root, so I think you guys should see that too. But we are going to follow the same steps here. So we're going to go ahead and isolate the radical. So to do that, I'm going to subtract 2 from both sides. Okay. And then once I have that, I have -8 is equal to the cubed root of x. Now I'm at step 2, right? I already isolated the radical. Now I have to undo the radical. So in the previous 2 questions, we were squaring to get rid of a square root. But now I have a cubed root. So what I do to undo a cubed root is to cube it, or in other words, raise it to the 3rd power. Okay? And once again, I have to do that to both sides. And I'm going to be very careful to put the left side in parentheses because it was a negative number. When I take -8 and I cube it, that is telling me -8 times -8 times -8. It's actually 3 negatives times each other. So if I cube a number that is negative, it actually stays negative. So we're going to have -8 cubed, which is a number that I, in theory, should probably have memorized, but I'm going to calculate it in my head real quick because for some reason I'm recording this video very late at night and I can't think. 512. Yeah, 512. Okay, so that comes out to -512. And then on the right side, again, the cube and the cube root, because they're opposite, they just cancel each other out. So those go away. And I'm just left with x. Okay, so this is telling me that x is equal to -112. Kind of a big answer. It's actually really small because it's negative, but whatever. Anyways, on to step 4. I'm going to go ahead and I'm going to check my answer. Okay, and that means I'm rewriting this original function with negative 512 in the cube root. Okay, negative 6 is there. If I'm going to take the cube root of negative 512, I understand if you don't know the answer to that off the top of your head, go ahead, use a calculator. Fun fact, in your iPhone calculator, just the standard normal one, if you are to flip it sideways, you actually do have a button for the cubed root. If you have a real calculator, that's even better. But either way, if you take the cube root of negative 512, you get negative 8. Okay. And then plus 2 leaves me with negative 6 is equal to negative 6. So this checks out. We are good to go. This is a real solution, not an extraneous one. So I'm just going to go ahead and circle it or put a box around it because I know that this is a real solution. Okay. So hopefully that was helpful. Now I'm going to move on to the second topic we're going to talk about, which is average rate of change. And if you remember, average rate of change is calculated the same way we talk about slope. So we are going to be following the formula y2 minus y1 over x2 minus x1. For the first couple problems here, we are given an equation and an interval and asked to find the average rate of change. So remember that an interval is giving me two x values. So this is giving me right here an x1 and an x2. So these are both x values. I need to use the equation to find the y value. So I'm basically going to write these as points, 1 and then some unknown y value. And then I also have the second point, 5, and some unknown y value. Then I'm going to have to go in and figure out what is this unknown y value. So I want to know what is the value of f when x is 1. So I'm just going to plug in 1, and it's 2 times 1 plus 3. That comes out to 5. So one of my points is 1 comma 5. The other value I want to know is what is the y value when x is equal to 5. So again, I'm just plugging 5 into that equation that I was given. So 2 times 5 plus 3, and that comes out to 13. So my second point is 5 comma 13. Now I'm going to use these points to plug into the slope formula. So I have my first point over here, and my second point is here. So my first point, I have x1 and y1, right? The one standing for the fact that it's the first point. And the second point has x2 and y2. So I'm just going to take these values. So if I'm looking for y2 is 13, right? If I'm looking for y1 is 5, okay? And then over x2 minus x1. So x2 is 5, x1 is 1. Okay. So 13 minus 5 would give me 8. Over 5 minus 1 gives me 4. And my average rate of change is 2. Okay. So after you have 2 points, really it is just the same exact thing as finding slope, okay, for a linear equation, right? The slope would be a little different for other functions, but it's the same formula. Like this formula right here is going to work for you for average rate of change. Yeah. Now we're going to look at a slightly different type of problem, and this is a problem that we are given a table. So it's actually a little bit less math to do here as long as you understand how to approach this problem. So based on the table of values below, find the average rate of change over the interval -3 to 1. So remember that these are x values. So I'm looking for 2 points. One x value is -3, and the other x value is 1. And I'm going to need to find the y values that correspond with these x values. Lucky for me, I don't even have to plug this into an equation because I already have a chart of x and y values. Remember that f of x is basically the same thing as y, so I can just write y up at the top there, and I know that this entire second column is giving me y values. So I'm just going to look at, okay, when x is -3, let me find that in the chart, and see what is the y value. And it turns out to be 5. And then I'm doing the same for where x is 1. It looks like in this case my y is -5. And then I'm just going to find the values to plug in to my formula, y2 minus y1 over x2 minus x1. Okay. And again, I always like to label my points because this helps me remember. Some people are really tempted to write x1, y2, all for point 1. So if you label, like this is point 1, this is point 2, it makes it a little easier for me to remember that both the x and y are 1. And then on my other point, I have x2 and y2. Okay. And then I just plug these values in. So you can see that y2 is -5. y1 is +5, so I'm subtracting 5. And then for x2, I'm looking right here, so that is a 1. For x1, that is a -3. So I'm subtracting because of the form right here. You see that in the equation, there was a minus, but I also have a negative number, so it's minus -3. Okay, and when we do minus and negative, sometimes we put the negative number in parentheses just to make it easier for us to see. That's not a requirement. You can just write 1 minus -3, but this makes it a little easier to see. So when we do that math, -5 minus 5 is -10. You can do the math for 1 minus -3, remembering that a negative minus a negative is the same thing as a positive. So this is really just 1 plus 3, which gives me 4. And then when I divide -10 by 4, I end up with -2.5. So my average rate of change is -2.5. Okay. Now we're going to do one last problem, and that problem is based on a graph. So how do I find the average rate of change for a graph? Once again, it is giving me an interval. So my interval is from 1 to 3. So from an x value of 1, whatever that point is, to an x value of 3, whatever point that is. So basically I'm talking about from here to here. I'm literally only looking at this part of the graph. I don't care about any of the rest of it. Okay. But what I'm going to do is I'm going to start by finding the y values at 1 and 3. So let me find what is the y value at x equals 1. Well, the point on the graph is actually right down there on the x-axis, so it appears my y value there is 0. And then for 3, I have to go all the way up here to find the point on this function, and it turns out that y value is actually over at +4. So that gives me 2 points of 1, 0, and 3, 4. And then again, I can plug into my equation, y2 minus y1 over x2 minus x1. Moving this along a little bit faster this time, just because I've done several examples with you on this. That would give us 4 minus 0 over 3 minus 1, which comes to 4 over 2, or 2. Okay. The other thing I want to point out is since we are looking at 2 points on a graph, and I said you use the same thing as slope to find average rate of change, basically I can figure out what would the slope of the linear function that attaches these 2 points be. So if I wanted to, I could also just count my rise over my run. If you ever do this, be careful that you make sure whether this is like positive or negative. But in this case, to get from point 1 to point 2, I have to rise up 4 and then go over to the right 2, which gives me 4 divided by 2, which comes out to 2, which you'll see matches the answer I just got, which is sort of goes to show that both of these methods are valid if you are given a graph. So you can either use the formula or you can count rise over run on the graph. If you are asked to show your work though, and you choose to use the slope on the graph, I would suggest that you go ahead and draw these dotted lines showing where you're getting the slope and write this type of thing here that says rise over run, just to make sure that your teacher would know where your answer is coming from. Okay. But so hopefully that was helpful. Again, I know that was two totally different concepts, but both of these are important. So if you do have any questions about either solving radicals or about average rate of change, please ask them sooner rather than later. Try to go back into your notes, into these practice problems. And if you still have questions, make sure you send your teacher, probably me, but if you're in another class listening, send your own teacher a quick email just asking them. Okay. So other than that, I will see you in the next video.